Hello, hello. Hello, am I audible? Okay, so let's start with today's class. Today we are going to cover three topics which are structures, unions, and enum. When we started our C class, we discussed that there are two types of data types. One was primitive data types, and the other one was user defined data types. Now, we have already discussed what are primitive data types. In this class, we will see how user defined data type works and what are actually the user defined data types. Okay, so the first user defined data type is structure. And why am I calling it user defined data type? We will see here. So in primitive data types, we have already studied int, float, char, and double. Okay, we have already studied these data types as primitive data types. But if you think about real world scenarios, the kind of data we deal with is completely different. We never talk in terms of int, char, float, double, right? In the day to day life, we never even use these words. What do we use? Okay, we have a data for a person, we have a data for an object, we have a data for a car. A car has four tires, a car has an engine, a car has an engine number. We don't talk like that a car has an engine integer number, right? We don't say like that. Okay, we never say that okay your phone number is an integer format. In day to day life we never speak like that. We simply talk in terms of data. Okay, I want to store this particular kind of data. I want to store age, I want to store phone number, I want to store address. This is the kind of data we deal with in day to day life. And for that we can't use primitive data types, right? Internally we are using these primitive data types, but to say, we never say that we are using int, char, float. We don't say things like that, right? For that, we have user defined data types. Now, suppose I want to store student details. Okay, I want to store details of a student. In this case, a student, suppose, can have a name, age, and roll number. Okay, a student can have name, age, and roll number. Now we know that age, roll number, name, these can be stored in these data types, right? But when I'm talking about a particular student, I'm just talking about one person. If I use these variables directly to store student details, for each student, I will have three separate variables. And suppose you have 1000 students, so you will have 3000 variables to handle in a code, right? if you store these things individually using these primitive data types, then a single student will have three variables. So suppose student 1 name is Rahul. So Rahul's name, Rahul's age, Rahul's roll number. Three variables for one single student. And if you have 1,000 number of students, their number of variables will be 3,000, and that will be very inefficient. And we don't have any single data type which can store all three information at once. We don't have any such data types. For that, we create structure, right? So multiple students can have three values. So it is not feasible for us to create individual variables for each of them. That's why we use structure. And let's now see how structure is used in this case. So instead of using individual variables, we will combine those variables into a single block and we call them as a structure. So how do we create a structure? We use this keyword struct, then we name our structure. Okay, we name our structure. I want to store the details of a student, so I have written student here. Now inside these curly braces, I have written age, name, this is a character array, and this is a roll number. So if you see internally, we are using the primitive data types, integer, character array, and then int. So internally, we are using those primitive data types, but they are now combined in this particular block, which is known as student. And here, I have created another data type, which is known as student, similar to what we have in our primitive data type. So int is a data type, name of the data type, right? Int is the name of the data type. Similarly, student is the name of data type which we have defined. Student is the name of the data type which we have defined. That's why we call it a user defined data type. Okay, because a user has defined this particular data type. Now we have created a data type which has three members. How do we use it? We have created a data type, but to use a data type, we have to create a variable using that particular data type, right? So to create a variable from this data type, we use this keyword struct again, then the name of the data type, and then the name of the variable. So it is similar to what we write normally, int x equals to 7. Here, sorry, here int is the name of the data type. Here, student is the name of the data type, which is created using this struct, and this x is the name of the variable. This s1 is the name of the variable. Okay, so this is how we create a variable for our structure. Now, if we have created this particular variable, this variable will contain all three members, and we can simply access them by using this dot. So s1 dot age, I'm setting the value 17. s1 dot name, I'm setting the value as Rohan, and s1 dot roll number is 28. So this is how we can access or assign the values to different members of a variable which we have created using this structure. Okay, so this is our own data type. This is what we have defined. So this is a user defined data type. This is how we create the variable using that particular data type, and this is how we assign values to different members inside that particular variable, right? So this is how we can create a variable. This is how to create a data type. Now there is another way how we can create a variable. So let me just erase this. Instead of writing struct student s1, what I can do is, where my struct is ending, I can, before semicolon, I can write like this. So now what happens is that with the data type, I have created a variable as well. Okay, I have created a variable along with my data type. So I don't need to write this particular line again. I can directly, after this, I can directly write s2.age, s2.name. So this is another way of creating a structure variable. Okay, so this is one method and this is also one method. You can create multiple variables by separating with a comma. So you can create s2, s3, s4. Multiple variables can be created at this particular place. Okay, so you can create variables either along with the structure or you can separately create them using struct keyword. Both of the methods are fine, right? So this is how we create structure and this is how we use those variables. Now we come to a very important concept of a structure which causes confusion in many students' mind. Okay, many students give a wrong answer for this particular question when interviewer asks them. Simple, a very simple part. Here I have created a struct sample. In this sample, I have three variables, int, char, and double. Right? We have three variables, int, char, and double. Along with this struct, I have created this s variable which belongs to this sample data type. Now I want to calculate the size of this variable. Right? We know that in C language we have this size of operator through which we can calculate the size of different types of variables, and I'm using the size of on this sample variable. Okay, what will be the size of this particular variable? Now the first thing that comes to students' mind is that since S has three different data types, if I just simply add the sizes of these individually, so int takes 4 byte, char takes 1 byte, and double takes 8 bytes. Okay, int takes 4 bytes, char takes 1 byte, and double takes 8 bytes. If you just add them, the answer will be 13, right? And most of the student will give this answer if they are not familiar with the concept of calculating size in case of structure. Right. So most of the student will give this answer 13, which will be wrong. In case of structure, we can't simply add the sizes of individual members. In case of structure, we can't do that, right? We can't simply add the sizes of individual members. So how do we calculate the size in case of structures? Let's see. So the size of a structure variable is not always equals to size of individual members inside a struct variable. So size of individual members inside a struct variable is not equals to the size of variable, right? And for that, we will now understand a very important concept, which is majorly asked in interviews if they want to assess your knowledge in C language. So it is a very important part, and the topic is structure padding, right? Now what happens is this was the variables inside our structure previously. If you see again, int, char, double. Okay, so these three variables we had in our structure. If you individually add them, the size was coming to be 13, which I said is wrong. Okay, the actual size in this case will be calculated based on structure padding. Okay, so how structure padding is applied and why structure padding is applied, actually we will look now, right? So what happens is, when our computer reads data from the memory, when our computer reads data from the memory, it actually reads several bytes at a time. Okay, it actually reads several bytes at a particular time. Why? Because suppose your integer is stored in 4 bytes, right? Your integer is stored in 4 bytes. So if your integer is stored in 4 bytes, that means your computer will have to read 1 byte at a time. Normally, if you think, your computer will have to read 1 byte at a time. Instead of doing this, what our computer prefers is that it reads several bytes at a time. It doesn't just reads 1 byte at a time, it reads several bytes at a time. Why? Because to read an integer, it will have to read 4 times. It will have to access the memory 4 times because our integer was stored in 4 bytes. So if it will read 1 byte at a time, to read one integer, it will have to access the memory 4 times, which is an expensive operation. To prevent this, the computer usually reads 4 bytes at a time. The computer usually reads 4 bytes at a time. That means once it accesses the memory, it can read 4 bytes at once. That's how it reduces its memory cycle. So reading 4 bytes at a time is considered as one memory cycle. Reading 4 bytes at a time is considered as one memory cycle. So our computer actually reads 4 bytes at a time. That means in one memory cycle, our computer reads 4 bytes. And for that, our computer aligns the data. So read this line: data types has natural alignment. Data types has natural alignment. What does this line means? Let me just erase the extra text. What does this line means? Is suppose we have memory addresses and consider that this each block is 1 byte. This each block is 1 byte. So this is total 4 bytes, this is 4 bytes, this is 4 bytes, this is 4 bytes, and so on. So each block is comprises of 1 bytes. And let me give the addresses to these blocks. Okay, so we are assuming that these are the addresses of each particular block. What happens is that since integer takes 4 bytes, the integer is stored at a particular address which is a multiple of 4. So the integer will be stored at that address which is a multiple of 4. That means integer can be stored from here, from here, from here, 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 here. Okay, we will not store integer starting from this particular block 1, 2 or 3 because these are not multiples of 4. So this is a rule that integer, since it takes 4 bytes, it will be stored at memory location which has an address in multiples of 4. So what happens is we have int x which takes 4 bytes. So this byte, this byte, this byte, and this byte. So this space is taken by our integer. Okay. Next, we have character. Character takes 1 byte. That means it can be stored at any address which is a multiple of 1, and every number is a multiple of 1. Okay. So we store character at this position because we have already occupied this. So the next memory location available is this one. So we store character at this particular point. Next, we have double. Double takes 8 bytes. Since double takes 8 bytes, it will be stored at a memory address which is a multiple of 8, right? Since double takes 8 bytes, it will be stored only at those memory location which is at multiple of 8. After 4, the multiple of 8 is this 8. That means double will be stored here and these 8 bytes 1 2 3 4 1 2 3 4, right? So if you see, these 3 bytes are unoccupied. Now it doesn't mean that this memory can be utilized later. It is not possible. This memory will not be utilized later, and this is what we call as padding. So we have added 3 bytes of padding, 1 2 3, 3 bytes of padding in case of this alignment. To align the data at a particular place, we have to leave 3 bytes of padding here, because as I said, since int is a 4 byte, it will be aligned according to the multiple of 4. So we can start int from this position. Since char takes 1 bytes, it can be aligned with a multiple of 1. So we can place char at this position. And since double takes 8 bytes, we can align double variable from the multiple of 8 only. So after this, the multiple of 8 starts from this position. So we take these 8 bytes. So actually, we took 4 bytes, 4 bytes, 4 bytes, and 4 bytes. So the size in this case will be 16 and not 13. We have added 3 bytes of padding. Okay, we have added 3 bytes of padding. Now let's do one thing. I will use again these 3 variables, these 3 data types only, but I will just change their order. Let me erase this. So earlier we had int, char, and double. I will again use these 3 only, but I will just change their order. So what I'll do now, I'll do int, double, char. Okay. So after int, I will now store double variable. In this case, our answer will get changed. Okay. Let's see how. First, we have integer. Integer is of 4 bytes. It can start with the multiple of 4s only. So we can store int at these 4 bytes. These 4 bytes will have int. Next we have double. Now double can be stored at memory locations which are multiple of 8. So we cannot store double from these positions. We can store double at this particular position. Okay, we have left 4 bytes of padding here. This particular space will be padding. We have left with char. So char will be stored at this position. Now you might think that in this case the size will be 4 plus 4 plus 4 plus 4, and since all of the memory is left, so this will be 17 bytes because we don't have anything after this one. Or some of you might be thinking about 20 bytes, right? So some of you might be considering that this part will be added as padding. So we have 20 bytes in all. But the answer in this case will be 24 bytes. Okay, the answer in this case will be 24 bytes. Why? It's because the alignment which we made is perfectly fine. But the padding will be considered till this point. That means these 3 and these 4 will also be considered as padding. And why? Because the total size of a structure variable, the total size of a structure variable should be the multiple of its largest data member. The total size of a structure variable should be the multiple of its largest data member. Out of these 3, the largest is double, which is 8, right? Which takes 8 bytes. So the total size of this particular variable should be the multiple of 8. And if you see 17 bytes, 20 bytes, these are not the multiple of 8. And after occupying 17 bytes, the next multiple of 8 is 24. After occupying 17 bytes in total, the next multiple is 24. Okay, we have started from 0, so 0 to 16 means 17 bytes. So after 17, the total multiple, the multiple of 8 is 24. Hence, this particular part will also be considered as padding. So to calculate the size of a structure variable, you need to consider padding. Without it, it is a very high chance that you are giving a wrong answer, right? It can be correct at certain point, but it is very likely that your answer will be wrong if you are not considering structure padding. Okay, to counter structure padding, now suppose you don't want the space to be left. You are saying that, okay, we are wasting too much space and I don't want it. You can simply use structure packing. So to counter structure padding, you will have to do structure packing. For that, you can simply write this particular line. You can write this particular line in your code, and this will force the compiler that we should not leave any space here or here. So no padding will be done. And in this case, you will get the exact answer which you were getting here. So in this case, you will get 13. So when you apply structure packing, your answer for this particular case will be 13. But if you are not applying structure packing, that means your computer is automatically using structure padding. So you have to consider padding in that case. So you can read more about structure packing online. You will get many articles, but using this is one of the method to apply structure packing and to ensure that we don't leave any space anywhere, right? So This is what structure padding and packing is. Now, next we come to union. Okay, so union is similar to structures in some way, like how we defined structures. In a similar way we write union as well. So instead of struct we use this union keyword, but union is used when only one member will be used at a time, right? In case of structure, we know that since it is a user defined data type, it can contain multiple value. Same with the union, it can have multiple values, but the twist is that in case of union, every member will share a common memory. In case of structure, every member had its own memory. Every member had its own memory. But in case of union, every member shares a single common memory, right? And this memory is according to the largest data type inside this union. So in case of this particular example, we have int, float, char. The largest one, you can see that int and float both take 4 bytes. So this memory space will be of 4 bytes. We take the largest members space to ensure that all of the members can be stored without losing any data, right? This is our union. To create a variable of union, you write union keyword, you write name of your data type, then you write variable, right? Now what happens is, suppose you assign a value d dot x equals to 7. Since we have the common memory, 7 will be stored at this particular location, right? 7 will be stored at this particular location. Next, you write d dot y equals to 8.8. So you now want to set the value in y. And since you had only one single memory, after running this line, your old data will be removed and your new data will get stored here. Since you had a common memory, your old data was removed and your new data got stored at this particular line. Okay, this is how union works. Now you might be thinking that if in case of union we can store only one value at a time, what is the use of it, right? If we can store only one value at a time, what is the use of it? For that, I I will explain this example. I will try to picture a scenario. If you see, suppose you are writing a code for any sensor, right? And for that you need sensor data. But at any point of time, you either want to check its temperature, you either want the value in humidity, or you either want the value in status, right? So at one particular time you want to check only one thing. You either want to check the temperature of sensor, you either want to check the humidity level, or you want to check the status. In this case, having the value in all three of them at particular time is not useful, right? Because at one time you need only one thing from the sensor. You either need the temperature, you either need the humidity, or you either need the status. You don't need all three of them at one time, right? So you need only one data from the sensor. For that, you don't need to store values in all of them. That will be the wastage of space. So instead of that, you create these as a union and they will share the common space, and That's how you can store the values, right? Another example which I can think of is that suppose a company is maintaining a data for salary. A company is maintaining a data for a salary, and the salary can be of three types. It is either for a trainee, it is either for an intern, or it is either for a full-time employee. So salary can be for trainee, intern, and full-time employee. Now, at a particular time, an employee will be either a trainee, he will be either a full-time employee, or he will be either an intern. He cannot be all three of them at one time. If he is a full-time employee, he will not be intern, he will not be a trainee. So in that case, you can use union, because at one particular time, only one of them will have the value. Okay, so this is the use case of a union. Okay, let's move to next topic. Next, we have Enum. Now, Enum is also a kind of user-defined data type, and it is used to make named constants. A constant is something which doesn't change its value, right? Which has a fixed value. That is a constant. And we make named constant. We provide name to a particular constant with the help of enum. Okay. Now the next question might be that what how does it make sense? Why we want to provide a name to a constant? Okay. Because it makes code more readable and easier to understand. To prove this, let's see an example. We have this particular code. Okay. Now suppose you are seeing this code, you are reading this code for the first time, and you read it. Okay, signal is equals to 1. You understood that we are assigning 1 to signal. Then in the if, we are checking if signal is equals to 1. We are comparing if the value of signal is equals to 1. We can say cars can go. Okay, you think that okay, we assigned signal the value of 1, and we checked if signal is equals to 1, then we can say that cars can go. Pretty simple. But it can be made better. How? See, if I write signal is equals to green, if signal is equals to green, cars can go. If you think about real world scenario, what makes more sense? Signal is equals to green or signal is equals to 1? In the real world scenario, we know that when we see the green light, we will go, we can go. So this particular code makes more sense than the previous one. It is more readable, it is more clear to us, and it makes sense that if signal is equals to green, cars can go, right? If we wrote signal is equals to 1, cars can go. Now, what is 1? 1 is a constant, simple, 1 is a constant. But it doesn't make very good sense if we think in terms of real world. In terms of real world, this makes more sense, because if signal is equals to green, we can say that cars can go. And why I am able to write this? Because I have given a name to a particular constant. I have given a name to a particular constant. And how I did that? I used enum. So I created an enum, I gave that enum a name, and in that I just wrote three things: red, yellow, green. Okay, I just wrote three things: red, yellow, green. Now when you write an enum like this, what enum does is that it automatically assigns a value to each of these. So red will be assigned a value of 0, yellow will be assigned a value of 1, and green will be assigned a value of 2. This happens automatically. So we don't have to write this. we write only names. So the first value will always be 0, second value will be 1, 2, 3, 4, and so on, right? Then we can create a variable with the help of my enum. So enum keyword, name of my enum, and the name of the variable, and this should be single assignment operator. And here I am assigning green in signal, and I am checking if signal is equals to green, cars can go. Internally, what is happening is I am assigning signal a value of 2 because green has a value of 2, and I am checking if signal is equals to 2. Internally, this is happening, but for us, if we want to read this code, we are reading if signal is equals to green, which is more readable, more understandable, it makes more sense. So this is how enum is solving our problem. It is making our code more readable. It is not something that without this your code will not work, right? It is not that type of data type. You can completely write your code without enum. It will work fine. But just to make it more readable, more understandable, we use enum. All right. Let's take a sample problem for a structure. We will discuss this. It is a very simple problem. Um, we have a struct sample which has 3 particular variables, and inside main function I am creating a variable using this structure, and I'm trying to print s dot a, s dot b, s dot c. That means s of a, s of b, s of c. So the usual responses that we will get 0, a, and 10.5, right? After printing s dot a, s dot b, and s dot c, we will get these values, right? But actually this code will give you a compile time error. Okay, this code will not run. This will give you a compile time error. And why? It's because we are not allowed to initialize the members. We cannot write like this. These members should always be uninitialized. Okay, these members should always be uninitialized. We cannot assign values inside this struct. So that's why this code will give you a compile time error. Okay, so this is all about structure, enum, and union. Okay, this is the topic of user defined data types which we have covered. The one thing which you should focus more and more is the topic of structure padding. If you understand it completely, it will help you a lot in case of conceptual questions asked in interviews. So if someone is testing your knowledge in structures, it is a chance that 99% chance is that they will ask you a question about structure padding. So in this video, I explained what is structure padding and why structure padding happens. Because as I said, computer does memory alignment to ensure that it reads maximum data at in a one memory cycle. Okay, so that is why structure padding happens, and to prevent that, we do structure packing. Okay, so this was all about today's class. If you have any doubts, you can send them in the comments once we have the recording on the platform, right? So that's all for today. We'll see you in the next class.